Hi everyone, we are Team Sutrangam. I am the member on this team. So, we are coming to the Smart India Hackathon. We are participating in the Smart India Hackathon 2025, and our problem statement is Namami Ganga Smart River Water Quality Surveillance Sampling System with the drones. So here our main aim is to collect the water samples from the river, and by using the sensors we can calculating the pH and turbidity and TDR, and it uploads the into the cloud, and the cloud sends the data to the ground station monitoring app. So coming into this, we are developing an indigenous drone. So we are included some feature in this drone. So the drone is developed from the scratch by us. So we are included some features in this. The features are the antenna for long range distances operations in remote areas. So it can also works when there is a no cell towers and signals and without internet, and it can also work with the internet and Wi-Fi. Implemented a redundant flight controls. If there is a mission, if there is a failure in this drone systems, it can go, which means where it is started, it comes back to this original position if there is a failure in the drone. So we are integrated some inbuilt filters and sensors. The sensor analog values is converted into the digital value, and it uploaded to the cloud, and the cloud sends the data to the ground station team. So here the main part of its drone is our water container. It contains with the inbuilt depth sensor up to 1 meter to 0.5 meters. So this container will collect the water samples with four slots and with four different types of water samples. Each consists of 250 ml, and total water capacity is 1 liter. So the weight is approximately 2 kgs with the payload and water container and all the components within the drone. So we already developed a ground station app to send and receive the data and monitor the health and what is the status and how to tracking of the drone included in an app. So coming to the next slide, we approached it technically by the 4-in-1 pH sensor, so it can directly sense the pH, light and temperature and water level. So it which is in the form of analog values. So these analog values are converted into digital values by the STM32F45 board. So this is the coming to this is the main controller and the brain of the drone. So can reduce the cost and is cost effective. So by this, we already said that the container is with the depth sensor, and the container capacity is 1 liter with the four slots, each slot containing the 250 ml. For obstacle avoidance, we used a 4 HCSR for ultrasonic sensors, four sensors which are integrated in the drone with four sides, and a lidar sensors to solid state lidar to obstacle detection and terrain mapping in GPS generated environments and for scanning the ground. So we are optionally integrated a NVIDIA Jetson Nano for the AI performance and AI controlling and obstacle avoiding, which can easily automated by this chip. So coming to the mobile app, so we are already developed a mobile app in this. Coming to the mobile app, so here we can see all the readings and the active drones and active missions, and we can also get the recent alerts, high wind warning, low battery alert, and we can easily monitor the what is the health of the drone. So after this we can upload the coordinates, so it can easily identify its own path by autonomous control. By updating the coordinates, it can select its own path. So we can also track the drone by in this app. So the main resources in this is this is the main tab. So we are included, and this the drone is also used for the disaster response, where in some remote areas, villages, like they are not some villages which are not very close to the cities. So if there is a disaster or floods like these situations, the drone will help to rescue and medical needs supplies by this drone. So by the kits, medical, food, water, and in this tab only we can also get the data of the pH, turbidity, and all of these things. So here we can see this in the messages tab. So it will sense the notifications. So what is the status and what is the situation among the environment in this tab? So this is about this is about the app we are developing in the back end of this app. So coming to the feasibility and viability, the technical feasibility is lightweight drone, it is GPS module and parasitic pumps and IoT sensors. So this is the technical feasibility. Material feasibility, corrosion resistant materials. Here we use it the carbon reinforced plastic, so it is the corrosion resistant. So it cannot be damaged by the rain. So we can easy and it has low density, and it can carry higher masses. So coming to the integration feasibility, we integrated the GPS, telemetry and cloud system for the geotagging and data transmission, requiring minimal hardware modification. So in the coming to the operational feasibility, the total payload of this drone is up to 2 kg approx. The system is within the capacity of the commercial drones. So coming to the viability, economic viability. The use of locally available materials and indigenous manufacturing reduces cost and dependency on foreign equipment. We already told about this is the indigenous drone developed by us from the scratch. So the market viability is high potential demand for the government programs, and it is also more helpful for the floods and disaster responses. Coming to the social viability, it gives the real-time data on pollution levels, benefiting communities. The impact and benefits. The first thing is the smart water collecting system. Coming to the smart water collecting system, and it can easily collect the water in the river, and it directly sends the pH, TDR, and turbidity and temperature of the water, and it is also integrated with a rain sensor integration with auto backup. So it has a AI real-time navigation and coordinate controlling, an app for coordination and communication for the ground team. So we are already shown the app previously, AI obstacle avoidance by autonomous control. So this is the reference video that generated in perplexity with the water explaining this. So here drone will collect the water samples in the from drone will collect the water samples from the river. So this is the reference that we want to demonstrate. So we are all included our research and references in this, that what softwares that we are used and the what softwares that we are used and the total calculations and sheets are presented in this. Thank you.